Friends, to IIT PAL problem solving session. Our topic is probability and this is lecture number 4. In the last class, we have solved several problems of probability, and as I said that we shall continue with solving more problems in this session. So, let us start with a simple problem. Suppose A and B throw a pair of dice alternatively. The game stops if A throws a total sum of 9 or B throws a total sum of 6. Assuming A starts first, what is the probability that B finishes the game? So, let E be the event or U1 be the event that the sum of faces is equal to 9. This can happen with the following cases. Three, 6, 4, 5, 5, 4 and 6, 3. Therefore, probability of E1 is equal to 4 upon 36 is equal to 1 upon 9. Let E2 be the event that the sum is 6. Therefore, possibilities are 1, 5, 2, 4, 3, 3, 4, 2 and 5, 1, and therefore, probability of E2 is equal to 5 upon 36. We know that A starts the game. Therefore, A finishes the game if A throws 9 first time and that probability is 1 by 9, A throws other than 9, then B throws other than 6 and then A throws 9, and this probability is 8 by 9 into 31 upon 36 into 1 by 9. A may finish the game in the 5th turn, and that probability you can easily calculate is going to be 8 by 9 into 31 upon 36, again 8 by 9 into 31 upon 36, and finally 1 by 9 is equal to 1 by 9 into 8 into 31 upon 9 into 36 whole square. As you can understand that A finishes the game only at odd turn, therefore, total probability that A finishes the game is 1 by 9 plus 1 by 9 into 8 by 9 into 31 upon 36 plus 1 by 9 into 8 by 9 into 31 upon 36 whole square. As you can understand that this is going to be a GP series is equal to 1 by 9 into 1 plus 8 by 9 into 31 upon 36 plus 8 by 9 into 31 upon 36 whole square plus this infinite series, and we know that the sum of this series is going to be 1 upon 1 minus 8 by 9 into 31 upon 36 is equal to 1 by 9 into 1 upon 1 minus 248 upon 324 is equal to 1 by 9 into 1 upon 324 minus 248 upon 324 is equal to 1 by 9 into 324 upon 76 is equal to 36 upon 76 is equal to 9 upon 19. Therefore, the probability that if A starts the game, then A finishes the game is 9 upon 19. Therefore, we can easily see that if A starts the game, then B finishes it has the probability (10/19). In a similar way, you can obtain the probability that A finishes the game or B finishes the game when B starts the first move. I leave it as an exercise for you to complete that part. Let us now do another problem. Let A, B, C be three events such that probability of A is equal to 0.3, probability of B is equal to 0.4, probability of C is equal to 0.8. Probability of A intersection B is equal to 0.19, probability A intersection C is equal to 0.2, and probability A intersection B intersection C is equal to 0.09. If probability A union B union C is greater than equal to 0.75, find the minimum and maximum value for probability B intersection C. Solution: we know that probability A union B union C is equal to probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of B intersection C minus probability of A intersection C plus probability of A intersection B intersection C. It is given that this is greater than equal to 0.75, and it is obvious that it is less than equal to 1. Therefore, 0.75 less than equal to probability of A plus probability of B plus probability of C plus probability of A intersection B intersection C minus probability of A intersection B minus probability of A intersection C minus probability of B intersection C, which is again less than equal to 1, or 0.75 is less than equal to 0.3 plus 0.4 plus 0.8 plus 0.09 minus 0.19 minus 0.2 minus probability of B intersection C less than equal to 1, or 0.75 less than equal to 1.2 minus probability of B intersection C is less than equal to 1. or -1 less than equal to probability B intersection C minus 1.2 less than equal to minus 0.75. Therefore, 0.2 less than equal to probability B intersection C less than equal to 0.45. Therefore, minimum and maximum values for probability B intersection C are 0.2 and 0.45. That is the answer. Okay, friends, let me now solve an interesting problem. Let A and B be two events of a random experiment E. It is given that one probability of A union B is greater than equal to 0.5, and 2 probability of A intersection B is less than equal to 0.375 and greater than equal to 0.125. Therefore, there are many different probabilities are possible for A and B satisfying the above. Let S be the region on 2D plane such that S is equal to x comma y, where x is the probability of A and y is the probability of B satisfying the above conditions. Find the area and perimeter of S. So, that is the question. Answer: it is clear that S is contained in the unit square 0, 1 cross 0, 1. So, if we draw the diagram, suppose this is 0, 1, 1, so this is the square. S is contained in this. We have to find the area and parameter of S. Now, given that (0.5) less than equal to probability of A union B less than equal to 1, because this is obvious. All probabilities are less than equal to 1. Also, it is given that 0.125 is less than equal to probability of A intersection B less than equal to 0.375. Therefore, 0.625 less than equal to probability of A union B plus probability of A intersection B less than equal to 1.375. Now, probability of A union B plus probability of A intersection B is equal to probability of A plus probability of B. Therefore, 0.625 less than equal to probability of A plus probability of B less than equal to 1.375, or this we can write it as 5/8 less than equal to, this is given to be x, this is given to be y less than equal to, this is 11/8. Therefore, suppose this is 5/8 and this is 5/8, let us draw the line. Also, suppose this is 11/8 and this is 11/8, and let us draw the line. Therefore, S is this region So, let us give name to different points. Let us call it O, P, Q. Let us call this line M, N, and suppose this line is X, Y, and this line is R, S. Therefore, S is the region given by P, X, Y, S, R, Q. Therefore, perimeter of S is the sum of the 6 line segments. What are these? This is 3/8, this is 3/8, this is 3/8, and this is also 3/8. These are the lengths. We need to compute the length of x, y, and we will compute the length of p, q. So, note that length of PQ is equal to square root of 5 by 8 square plus 5 by 8 square is equal to square root of 2 into 5 by 8 square is equal to root 2 into 5 by 8, and length of this xy is equal to root over 1 minus 3 by 8 whole square plus 1 minus 3 by 8 whole square, because this point is 3 by 8 comma 1 and this point is 1 comma 3 by 8 is equal to square root of 2 into 5 by 8 whole square is equal to root 2 into 5 by 8. Therefore, this is equal to 2 root 2 into 5 by 8 plus 3 by 8 into 4 is equal to root 2 into 10 by 8 plus 12 upon 8 is equal to 1.41 into 10 divided by 8 plus 12 by 8 is equal to 26.1 by 8, which is approximately 3.26. Therefore, this is the perimeter length. We need to find out area of S. If we go back to the diagram, we can compute the area of this triangle, from which we minus this area and this area. Therefore, area of S is half into 11 upon 8 whole square minus half into 5 by 8 whole square minus half into 3 by 8 whole square minus half into 3 by 8 whole square is equal to 1 upon 2 into 8 square is 64, 11 square is 121, minus 5 square is 25, minus 3 square is 9, minus 9 is equal to 78 upon 128 is equal to 0.609. So, this is the area of S. So, the answer is perimeter is equal to 3.26, area is equal to 0.609. 609. Another problem, suppose the sample space of a random experiment is 1, 2, 3, 4, 5, 6, where each element is equally likely. As I said earlier in the last class, that means that all these 6 elements have equal probability of occurrence, that is 1 by 6. If A and B are 2 independent events, then compute the number of ordered pairs A comma B such that 1 less than equal to cardinality of B less than equal to cardinality of A. So, I hope you understand the problem. There are 6 elementary events in the sample space. They are equally likely. We want 2 events A and B such that they are independent. Now, we want to see how many such pairs are possible such that cardinality of B less than, let us make it strictly less than cardinality of A. How to solve it? Note A and B are independent if probability of A intersection B is equal to probability of A into probability of B. Illustration. So, before going into solving the problem, let me illustrate. Say B is equal to, suppose 1 comma 2 and A is equal to 1 comma 2 comma 3. Therefore, probability of B is equal to 1 by 3, probability of A is equal to half, and probability of A intersection B is equal to probability of 1 comma 2 is equal to 1 by 3. Therefore, probability A intersection B is not equal to probability of A into probability of B. Therefore, in this case A and B are not independent. But consider B is equal to 1 2, A is equal to 1 comma 3 comma 4. Therefore, probability of B as before is 1/3, probability of A is equal to half and probability of A intersection B is equal to probability of singleton 1 is equal to 1 by 6. Therefore, probability A intersection B is equal to probability of B into probability of A. So, this is a case when A and B are independent and cardinality of B is less than cardinality of A. How many such pairs are possible? That is the question. Solution: suppose cardinality of A intersection B is equal to x. Therefore, probability of A intersection B is equal to x by 6. Now, probability of A is equal to cardinality of A divided by 6 and probability of B is equal to cardinality of B divided by 6. Therefore, x by 6 is equal to cardinality of A by 6 into cardinality of B by 6 implies 6x is equal to cardinality of A into cardinality of B. Therefore, A and B should be such that cardinality of A into cardinality of B is a multiple of 6. Therefore, if cardinality of A is equal to 6, then cardinality of B can be 1, 2, 3, 4 or 5. That is, if A is the full set, but we take B to be any subset, then how many such possibilities are there? B can be of size 1, that can be done in 61 ways. B can be of size 2, that can be done in 62 ways. Similarly, 63 plus 64 plus 65 is equal to 6 plus factorial 6 upon factorial 2 into factorial 4 plus factorial 6 into factorial 3 into factorial 3 plus factorial 6 into factorial 4 into factorial 2 plus factorial 6 into factorial 5 into factorial 1 is equal to 6 plus 15 plus 20 plus 15 plus 6 is equal to 62 ways. Now, obviously, cardinality of A cannot be 5. If cardinality of A is equal to 4, then cardinality of B has to be 3, because 4 into 3 is 12 and that is a multiple of 6, and cardinality of A intersection B has to be 2, because that has to be 6x, that is 12, therefore, x is equal to 2. Therefore, possible cases are, we can choose out of 6, 4 elements for A in 6C4 OS. Out of these 4, I can choose 2 in 4C2 OS, and out of the remaining 2, I choose 1 for B, that is 2C1 OS. Therefore, the answer is 15 into 6 into 2 is equal to 180. Now, cardinality of A is equal to 3. Then cardinality of B has to be 2, and A intersection B should have only one element. Therefore, number of ways is 6C3 into 3C1 into 3C1. Out of 6, we choose 3 for A. Out of these 3, we choose 1 for B, and out of the remaining 3, we choose 1 for B, is equal to 20 into 3 into 3 is equal to 180. Therefore, total number of possibilities such that cardinality of B is greater than or equal to 1 and which is strictly less than cardinality of A when A and B are independent is equal to 62 plus 180 plus 180 is equal to 422. So, that is the answer. Okay, friends, we have solved several tricky problems on probability. Now, it is time to move on, and we shall now start another chapter, that is conditional probability. Suppose A and B are two events which are not independent. In that case, the occurrence or non-occurrence of B may have an effect on the occurrence or non-occurrence of A. Consequently, the probability of A, given that B has occurred, will be different from probability of A without the knowledge of occurrence of B. So, this is the basic philosophy of conditional probability. So, to illustrate, consider rolling a fair die. Therefore, probability of 1 is equal to probability of 2 is equal to probability of 6. Therefore, probability of 2 is equal to 1 by 6. So, let A be the event that 2 has occurred, and B be the event that an even number has occurred. Therefore, if B is known to have occurred, then probability of A is equal to probability of 2 given that 1 of 2, 4 or 6 has occurred. Therefore, probability of 2 given even number has occurred is equal to 1 by 3, because it is one of these 3, each are equally likely, therefore 1 by 3. This is different from what we had earlier without the knowledge that B has occurred. So, this is the very basic of conditional probability. How do you obtain that? Probability of A given B is equal to probability of A intersection B divided by probability of B. So, in the above case, A intersection B is equal to singleton 2 and B is equal to occurrence of 2 or 4 or 6. Therefore, probability of A given B is equal to probability of 2 divided by probability of 2 or 4 or 6 is equal to 1 by 6 divided by half is equal to 1 by 3, which we have obtained. So, this is the basic knowledge of conditional probability. Let me do a problem which involves the concept of conditional probability. So, the problem is as follows. Consider a bag containing 12 red balls and 8 green balls. We take out 3 balls in succession without replacement. And suppose we want to know the conditional probability that the second ball is green, given that the first ball is red. So, how to solve these problems? Let R1 be the event that the first ball is red, and G2 be the event that the second ball is green. Therefore, we are looking at probability of G2 given are 1. Now, initial configuration is 12 red balls plus 8 green balls. Therefore, suppose the first one is red, then after taking out the first ball, the configuration of the bag is going to be 11R plus 8 green. As you can understand, we started with 12, 8, where 12 is the number of red balls and 8 is the number of green balls. Therefore, now if G2 happens, the configuration is going to be 11, 7. Therefore, probability G2 given R1 is equal to choosing of one of the green balls out of the total of 19 balls. Therefore, it is going to be 8 upon 19. Now, we know that probability of A given B is equal to probability of A intersection B upon probability of B. Therefore, we can write as probability of A intersection B is equal to probability of A given B multiplied by probability of B. That is, for this problem, therefore, we can write it as probability of R1 and G2 is equal to probability of G2 given R1 multiplied by probability of R1 is equal to, the first one is 8 upon 19 and this term PR1 is equal to probability that the first ball is red, that is, out of the 20 balls we are choosing any of the 12, that probability is 12 upon 20 is equal to 8 upon 19 multiplied by 3 upon 5. That is how we get the joint occurrence of R1 and G2, its probability. Now, suppose the second problem is, what is the probability that the third ball is green given that the first two balls drawn are of the same color. Therefore, the given condition is ball 1 drawn and ball 2 drawn are of the same color. That is, either both of them are red or both of them are green. That is, probability of G3 given R1 R2 plus probability of G3 given G1 G2, and perhaps you can easily understand what this notation is. R1 is the first ball drawn is red, R2 is the second ball drawn is red, and similarly G3, G1, G2 are corresponding to green color. Therefore, we have this situation 12, 8. After R1 we come to 11, 8. After R2 we come to 10, 8 and G3, then we will come to 10, 7. On the other hand, if the first one is green, then we come to 12,7. Second one is also green, then we come to 12,6, then we come to G3, and that is going to be 12,5. So, what are the probabilities? This probability is 12 upon 20. Drawing a red ball, again drawing a red ball, that probability is 11 upon 19, and now drawing a green ball, that probability is 8 upon 18. In a similar way, this probability is 8 upon 20. Now we have 12 and 7. So, drawing a green, that probability is 7 upon 19, and then drawing a green, that probability is going to be 6 upon 18. Therefore, probability of G3 given R1, R2 or G1, G2, note that these are disjoint events, is equal to 12 upon 20 multiplied by 11 upon 19 multiplied by 8 upon 18 plus 8 upon 20 multiplied by 7 upon 19 multiplied by 6 upon 18 is equal to 12 into 88 plus 8 into 42 divided by 20 into 19 into 18 is equal to 8 times, this is 11 into 12 is equal to 132 plus 42 divided by 20 into 19 into 18. We can cancel this with by 4, therefore, we have 2 and 5, and this I cancel with this, which is 9. Therefore, we have 174 upon 19 into 9 into 5. We can further cancel it with 3, but okay, let me do it. This is 58, this gives us 3, therefore, we get 58 upon 19 into 15. Okay, friend, I stop here today. In the next class, I shall continue with conditional probability and will solve several problems, and I shall start with the same problem and I will show some more important results. Okay, friends, thank you so much.